Have you ever wondered why adding two standard vectors is slower than using raw arrays? If you're working with large data sets, this can be a real headache. Today, we're diving into this performance mystery and uncovering the reasons behind it. I totally get it. You're not alone in feeling frustrated when your code runs slower than expected, especially when you're dealing with millions of elements. This is a common concern among developers, and it's important to understand what's happening under the hood. One user recently asked, why is adding two std vectors slower than using raw arrays? They noticed a significant difference in performance during the addition process, especially when using OpenMP for parallel processing. Sound familiar? Let's explore this together. So what's going on here? The difference in performance often comes down to how memory is managed and how the compiler optimizes the code. Standard vectors have additional overhead compared to raw arrays, which can impact speed, especially in tight loops. And stick around. I'll share some optimization tips at the end that could help you improve your code's performance significantly. To understand why adding two standard vectors is slower than using raw arrays, the user should first consider the overhead associated with std vector. Unlike raw arrays, std vector includes additional features such as bounds checking and dynamic resizing. Next, the user should examine how memory allocation differs between std vector and raw arrays. Raw arrays are allocated in a single block of memory, while std vector may involve multiple allocations, especially if it needs to resize. The user should also consider compiler optimizations. When compiling with different optimization flags, such as -02 or 03, the compiler may optimize raw arrays more effectively than std vector, leading to faster execution times. Finally, the user can experiment with different configurations and optimizations. They should try compiling their code with various flags and compare the performance of std vector against raw arrays to see the impact of these changes. Fun fact, did you know that the first C++ standard library implementations were much slower than today's versions? We've come a long way, but performance issues can still pop up unexpectedly. Now, let's look at the answers provided by other users. This user highlights that meaningful benchmarking is challenging. They explain that std vector initializes data to 0, while raw arrays do not. This initialization can impact performance, especially in loops. They suggest a minimal example to measure the time taken for operations with and without initialization, showing that initialized memory leads to more cache loads and TLB misses, ultimately slowing down the loop. They conclude that the performance difference arises from the loop's execution time, which is affected by whether the memory is initialized. The std vector itself does not add overhead to the loop, but the initialization process does. Let's take a look at another answer from another user. One user proposes a hypothesis to explain the performance difference between std vector and raw arrays. They created 3 versions of the code, one using raw pointers, one with std unique PTR, and one with std vector. They found that std vector was slower due to additional memory initialization calls, specifically memset, which raw pointers do not require. The user explains that both std vector and std unique PTR have a contract to initialize memory, while raw pointers do not. This leads to std vector being slower in scenarios where initialization is not needed. They also note that when zero filling is added to raw pointers, the performance becomes comparable. That wraps up that answer. Let's move on to another one. The user explains that the performance difference between std vector and raw arrays is due to how modern operating systems manage memory. When using std vector, memory is allocated in 2 stages, reserving virtual memory and then backing it with physical memory upon access. This can lead to slowdowns due to soft page faults when accessing uninitialized memory. In contrast, raw arrays initialized with operator new can access a 0 page, which is faster because it doesn't require physical memory allocation. The user also notes that the size of the arrays plays a role. With large arrays, the data must be brought from main memory, which can be slow. Raw arrays, when uninitialized, only require minimal data to be read, significantly reducing the amount of memory accessed during operations. That's it for that answer. Let's take a look at another one. This user found that the runtime for StevVector was about 1.8 times longer than for raw arrays, but only when the raw arrays were not initialized. After initializing the raw arrays with zeros, the performance difference disappeared. They also noted that using a conditional check during initialization did not produce any console output, which kept the raw array performance fast. This suggests that the way arrays are initialized can significantly impact performance. The user concluded that StevVector does not have significant overhead in normal usage, and the observed slowdown was due to specific conditions in their tests. They also mentioned that optimization settings affected the performance results. That's the end of that answer. Let's see another perspective. The user points out that the raw array version has undefined behavior because it reads uninitialized values. This means that the results of the addition may not be reliable. They emphasize that fixing this undefined behavior is crucial for accurate measurements and comparisons. They explain that because of this undefined behavior, the compiler can optimize the code in unexpected ways, making the performance comparison misleading. In essence, one program computes a valid sum, while the other may not compute anything meaningful. Here's a pro tip. Always profile your code to identify bottlenecks. This will help you make informed decisions about whether to stick with StevVector or switch to raw arrays for performance-critical sections. And there you have it. Understanding the performance differences between StevVector and raw arrays can help you optimize your code. If you found this video helpful, don't forget to subscribe for more tips and tricks.